All right, so this is the second video for rational expressions and functions, and we're simplifying rational expressions right now. So notice on this one we have x minus 4 divided by 4 minus x. X minus 4 and 4 minus x are opposites, meaning opposites in signs. So if you look at the x's, in the numerator I have a positive 1x, in the denominator I have a negative 1x. On the 4's in the numerator, it's negative 4. Denominator is positive 4. So they are opposites. And that means that they're equal to negative 1. So when you recognize this, for just simplifying, you could say, oh, it's just equal to negative 1. Now, if I take the 4 minus x and I factor it, if I factor out a negative 1, then if I take negative 1x divided by negative 1, it's a 1x. 4, let me just do it this way first. So if I divide 4 by negative 1, I get negative 4. If I divide negative 1x by negative 1, I get a positive 1x. And so I usually write it this way immediately instead of writing it the way I did at first, but I'm just showing you that that's what happens, right? When you divide by negative, it switches signs, but also we want to switch the order so that we have it in descending order. And then I have x minus 4 over negative 1 times x minus 4. And that means that I can take out my common factor of x minus 4, which equals 1. And I'm left with 1 over negative 1, which is negative 1. Okay. So sometimes you're going to need to factor out the negative 1 depending on what operation you're doing at that point. When we're just simplifying, we could get by with just leaving it written that way, knowing that opposites are going to equal negative 1 when one's in the numerator and the other's in the denominator. So let's look at this next one. I'm going to factor the numerator as a difference of squares, so x plus y times x minus y. And then in the denominator, I have, oh gosh, y minus x. So x minus y and y minus x, those are opposites. When I divide, I get negative 1. Now, what do I do with that negative 1? Well, in this case, I could just write it a negative in front of the x plus y in parentheses. Or I could distribute that negative 1 and it would be negative x minus y. Sometimes this is confusing, so you might just have to work on this a little bit to help you understand it better. All right, let's look at the next one. We're still simplifying. Okay, so on this we need to factor the numerator. Notice it's a trinomial and the denominator is also a trinomial. So we're going to factor. Now, if you need to use the AC method, then you're definitely going to want to go over to the side to do so. So for instance, on the 3x squared minus 11x plus 10, maybe I come over here and factor that, right? Because I'm going to find factors of 30 that have a sum of negative 11. And then I'm going to find those two numbers, which in this case are negative 5 and negative 6. I have a lot of squigglies going on there, right? And negative 5 plus negative 6, that equals the negative 11. So I replace my middle term with two terms, and then I group and factor. So common factor is x, that leaves me 3x minus 5. The common factor here has to be a negative because I have a negative here, right? So that's going to be negative 2, and that leaves me 3x minus 5. So here's factored form. 3x minus 5 times x minus 2. And I can go ahead and write that in my numerator then. And then in my denominator, this one factors, we actually factored it earlier when we were finding domain, I believe. That's x minus 5 times x minus 2, right? Factors of positive 10 that have a sum of negative 7. So my common factor then is the x minus 2, right? That's going to equal 1. And I'm left with 3x minus 5 over x minus 5. Now, a common mistake for students is they want to mark out the negative 5. But you guys, negative 5 is connected to the x or the 3x. So it makes a binomial. You can't just mark it out, right? It doesn't work that way. The only thing that you can remove is anything that equals 1 when we divide, and that means we have to factor it out to do so. So when it's in factored form, we can do that. But these are not in factored form. They don't factor any further, and so they're each a binomial with a negative 5. Okay. So the nice thing about multiplication and division actually is that they go right along with simplifying, really, because the operations are basically that we factor everything we can and we remove anything that equals negative 1. So multiplication basically is straight across. Now when it says multiply, actually we mean let's factor first, and then we're going to put everything side by side, right, the multiplication part, and then we're going to remove all of our common factors that equal 1. So let's look at this, the first, I'm trying to decide how I'm going to do this. I don't want to be confusing here. So, okay, so I would like to have negative 2x plus 10. I would like to factor out a negative on that. So I'm going to rewrite this in factored form, and I'm going to take out a negative 2, which leaves me x minus 5, because remember I'm dividing both terms by negative 2. And then I'm going to factor the 14 as 2 times 7, and I'm doing that because I see that I have a 7 in the denominator, right? So I know that I'm going to be able to remove a common factor of 7. So in my denominator, I'm going to write a 7 times, on the 5x minus 25, I factor out a 5, and then that leaves me x minus 5. So I can remove my common factors. Whoops, I don't know what happened to my 5 here. I can remove my common factor. Okay, I'm going to wait a second there. My common factor of x minus 5, right, that equals 1. And then my common factor of 7, and that equals 1. Remember, I have to be taking 1 divided by the other one, and that's where I get that it equals 1. Okay, and so then I can write out my answer. I'm going to go over here to the side. I just multiply what's left, which is negative 2 times 2. And then in the denominator, I only have a 5. So it's simplified all the way to negative 4/5. All right, next. Okay, so this one has quite a bit of factoring as well, and I'm going to factor everything possible here. On the denominator of the first expression, I'm going to go over to the side on this. This is just an organizational thing because these get so big and messy. You want to be careful and not end up with just such a mess that you don't know where you are. So I'm going to factor out a b. The only option I have here is grouping because there are no common factors, so I group. You can probably hear my dog again in the background. So this factors as a minus 2 times b plus 3. All right, so let's go back. And that's what's going to go in the denominator here, right? A minus 2 times b plus 3. And then in that denominator, it's also going to be a 3 times a plus 2 because I factor out the 3. In the numerator, I have a common factor of 4a on the first expression, and then that leaves me a minus 2. And then on the second expression, I have a common factor of 8, and then I'm left with b plus 3. And so now everything's factored, and that is the goal, right? We factor everything out, and then we remove common factors that equal 1. Okay, so a minus 2 goes into a minus 2 one time. We have a b plus 3 in common, and then that's a one time. And then I multiply what's left. In the numerator, I'm going to have 32a, and then in the denominator, I have 3 times a plus 2. Now, typically we don't multiply that out and make it 3a plus 6, but that's actually okay if you wanted to do that. Normally we just leave that in factored form. Okay, so I'm going to try to do one more so I get the multiplication part of this. I know what's going to happen in this numerator, so I'm going to factor out a 2 and just write it up there, so that leaves me with not having to write an extra step on that. Okay, so I'm going to factor everything that I can. So I keep this 2, and that's x squared minus 1, so x minus 1 times x plus 1. And then a common factor of 12, and that leaves me x plus 3. In my denominator, I factor out a 10, so that's x plus 3, and a 3. So 3 times x minus 1. Then I remove everything I have in common. So there's different things going on here, but I have an x plus 3, x minus 1 in common. I also have a 3 that goes into the 12 4 times. And then I have a 2 that goes into the 10 5 times. And you know that there's just a 1 on those two parts, right? That's what's left. And so then I'm going to multiply out what I have left. And so in the numerator, I simply have a 4 times x plus 1. And in the denominator, the only thing I have left is a 5. Now, you could take 2 times 12 and make that 24, and 10 times 3 in the denominator for 30, but you would still have to simplify that to 4/5 on the next step. Okay, so I'm going to end this video here, and then on the next video, we will be working on division.